Oh. Uh, Wait a second. Three through five. Mm-hmm. Oh, they had to put the dog in the place. Ah. This is 3.8. Alright, let's just label each one so that we know. You know it's 3.8. It says 3.9, but I'll just put it. It's at the bottom, it says 3.9. It says it at the top. It says it at the top. It says it at the top. And this says it here, and this says it here. Alright. Bet. Bet. Man. Meow. Meow. An equation that represents all asymptotes. Mm. Uh. Oh my god. Here's all asymptotes of the graph of f in the xy plane. Pi over 6. So pi over period equals pi. Write an equation that represents an equation that represents all asymptotes of the graph xy plane. 3.8 pre-calc. 3.8 pre-calc.
So rather than memorizing all the asymptotes, let's look at tangent. After asymptote, after asymptote, after asymptote, right? So rather than trying to list the asymptotes, we can write an equation that represents all of the asymptotes. And if we keep on going, we see that if we just keep on adding pi, we're just going to keep on getting asymptote after asymptote after asymptote after asymptote, right? So rather than trying to list the asymptotes, we can write an equation that represents all of the asymptotes. And so what we do is rather than just like saying this, we know that to, and again, you can look at it this way as well. As you get to pi halves, the distance to the next asymptote is halfway around the circle, which is pi. And then if you add pi again, and then add pi again, and then add pi again, or subtract pi, subtract pi, subtract pi, subtract pi. Every single time you add or subtract pi, you're going to get to an asymptote, as long as you start at an asymptote. So therefore, we say, well, where do we need to start? And again, you can start any asymptote. As long as you know what one asymptote is, start there. Typically, on a multiple choice test, they're going to provide the smallest positive as your asymptote. So we would say x is equal to pi halves. And then to get to the next one, I'm going to have to add or subtract pi. But to represent the adding and subtracting, we're going to use n. So we'd say x equals pi halves plus pi n. And that is the equation for the asymptote for tangent. Now, let's go and look into cotangent. Cotangent theta is x over y. And if we look at the asymptotes in this case, this is when it's the x coordinate over the y coordinate. And we see there's an asymptote at x equals 0. No. And at x equals pi. And again, if we notice this, 0 to pi, the next one is going to be at 2 pi. Ah! 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 So the smallest positive asymptote I have is 0, and then the distance between each asymptote is, again, pi, but to go positive and negative, we're going to use pi n. So we'd say x equals 0 plus pi n. Well, we don't really need to write the 0 there, so we can just say x equals pi n. I'm not memorizing anything. I'm just looking at 4 coordinate points on the unit circle to understand where my asymptotes are. Yes?
When we write asymptotes, do you want us to write x does not equal or x does equal?
X does equal. If it's in the domain, then those are undefined values. But x equals is the correct version for that.
terminal array. These two things mean exactly the same thing. It's just worded differently. So if you see evaluate tangent of an angle, it's the same. Over 1, or in other words, square root of 3. So the slope of that terminal array right there divided by x. So we get, we find nothing larger the vertical asymptotes first. If you can't do the vertical asymptotes, it's going to be really hard to sketch the graph of these. All right, so then, well, maybe some of you will. And then we're going to do another one. Where's the other one? At what? 3 pi over 2. And so notice that we have a little coefficient in front of theta. Then it changes the period. The period is then pi over b. That's the period of tangent, where you have a coefficient here. Please don't get this confused. Remember when we did sine and cosine? Sine and cosine was 2 pi over b. We've done that a whole bunch for sinusoids. Do not get that confused with tangent, because with tangent,
What happened? I
it's not 2 pi over b. It is pi over b. You've got to be able to interchange between the two of them, knowing when you're dealing with tangent, when you're dealing with sine and cosine. Periods are different. Okay, so if you have this tangent of b theta, then that's going to change how often you have your vertical asymptotes. I'm going to explain this a little bit more here in just a second. So just get this written down, and then when we practice it, it'll make more sense. So here's these two things here. The vertical asymptote is going to appear at every pi over 2b.
They will take you out to play basketball. Both of them. Anna and Anna. Anna and Anna. They will take you out to play basketball.
So it's going to actually be half of the period is where the first vertical asymptote appears, and then it's going to repeat every period. So it's just k times a period. Pi over b is the period of tangent. So it's integer values of k. You just do multiples of the period. All right, that might seem a little confusing. Let's just do a problem real quick here on here, and I think this will make sense. Okay, so the period, what's the period for this thing? The period is going to be pi over b, which is 2. So if I have I'm going to sketch this real quick. If I have my vertical asymptotes surrounding the origin here, the tangent's going to be right in the middle of this, in between these. Where are these vertical asymptotes? Well, if the is all of the vertical asymptotes for that function. Vertical distance is 3 pi over 2. So plus every k 3 pi over 2. Every period where
No. 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 Wow. No. Thanks. No. 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 Wrap each function. Tangent. Very easy, very easy. Very easy, very easy. So 1 just means that's increased. So it starts at pi over 2. Start with graphing the parent function. 2. And then you move over. So you factor out. So it's 1/2 tan 2 times theta minus pi over 4 plus 1. So we move right pi over 4. So let's start with that. We move right pi over 4. Boom, 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 boom. And we move this. Okay. And then we find where our asymptotes are. Oh shoot, I probably should have done that first. Okay. So that's pi over 2b is the first one. Pi over 2b is the first asymptote. Okay. So 2b, so pi over 4. Pi over 4 means it's here, and then you move right 1, so here. Pi over 4 is here, and you move right 1, so, or pi over 4, so it's here. And then you add 1. And you add 1. And then you go by 1/2. So let's find
on
this.
the right. These one tangent terminal ray, and I'm going to rotate it around the unit circle just to get a feel for what tangent is doing. So remember, tangent is the slope of this thing. So what does the slope start off with when we're in standard position? Right at the very beginning, the slope starts at 0. Slope of a horizontal line is 0. So now as we start moving around the unit circle, what's happening? The slope is positive, and the slope is positive, and more positive, and more positive. It's getting really, really steep. What's happening to it? It gets larger until it approaches infinity. It's approaching infinity as it gets bigger and bigger and bigger and bigger until we get right to pi over 2. Now all of a sudden you have this vertical line. What's the slope of a vertical line? Undefined. So we now have undefined there. Then what happens next? As we keep going, the slope right there, as we pass that point, the slope is now negative. And that's getting less negative, so the slope's actually getting larger. So it was super negative, and it's getting larger as we get towards 0. Once we reach right here, what is that angle right there? That angle is pi. So once we get to pi,
That's okay.
let's take this 2 and factor it out so that we can see what the phase shift is. So 2 times theta minus, this just leaves us with pi, right? No. That's wrong. So theta minus, what is it? Oh, pi over 4. Oh, that was tricky. Yeah, because now if I distribute the 2, I would then get back up here. All right, so now that helps us with the phase shift. So now let's do the period. The period is pi over b. Not 2 pi over b, just pi over b. In this case, a 2. So if we have that, that means I have a vertical asymptote at half of that. Right? So I have a vertical asymptote at x equals half of that, pi over 4. So don't graph it. I'm just going to show you where that would be. It would be right there. Again, do not sketch this yet because I want you to see what we're doing. So then from this, here's how this. I'll show you. It looks like pi over 2. So sketch all of those. Okay, that's a lot of vertical asymptotes. Okay, now what? We've got, let's find the point of inflection. So the point of inflection will be right in the middle of these things, but we had to shift it up 1, right? So this up 1 comes into play. So there's my up 1. That's a point of inflection. So go ahead and dot all the points of inflection real quick. Okay, your graph should look something like this so far. That's what our sketch is. Now we're going to remember that tangent is going to go up. It's going to go concave with a quick trick. Half. That is actually the value right there. So halfway between the point of inflection and the vertical asymptote, you go from the point, and this is kind of a quick, a nice little trick to help with the sketch. If you go half, and this is kind of a quick, a nice little trick to help with the sketch. If you go halfway from the point of inflection to the vertical asymptote, halfway in between, and then you go up a units, which in this case is a half, that is actually the value right there. So halfway between the point of inflection and the vertical asymptote, you go up a units. So you can do that real quick. And then you do the same thing the other direction. So you go the other direction, but you go down a units. And so then it would be like that. Go ahead and put those dots real quick. And then from here, it's sketching. Now be careful here. This is not a straight line, right? We're not just connecting these. We want to go on the right side here where it's going up, it's going to be concave up. So just kind of try to make it, if you're any good at it, concave up for each of those. And then on the left side, it's concave down, and you just try to hit that thing, and then the vertical asymptote will push your graph down. So again, it's just a sketch. The vertical asymptotes are very important, and the point of inflection. You want to make sure those are accurate for sure. And then from there, it's just kind of a little bit of a sketch for understanding the graphs. All right, number 8. This would be a really good one for you to pause this video, try this one on your own.
Okay. So just keep putting these here. All right. This factor y equals minus 310. Factor out 1/2 theta plus pi over 4 divided by 2. I mean multiply by 2, multiply by 2. What am I doing? Multiplied by 2 multiplied by. Because, yeah. Wait, what? Okay, so take out 1/2. Yeah, okay. Minus 2. So pi over 2b is the first one, so pi over, it's just pi. Boom. And then you go right pi, or left pi. So then it's just boom, boom, and then it's pi over 2b is pi, 2 pi over 2 cancels out, and then pi over b is 2 pi. So then you come over pi over, wait, here pi over 4, and then you move right. Oh shoot, I messed this up. And then pi over 2b means pi minus pi, and then left pi, so that's right here. And then you're gonna add a whole pi right here. Epic. And then you're gonna go minus 2, 1 and 2. And then you have a reflection right here, and then you have 3. So 1, 2, 3. Oh, okay, 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. It's gonna come off the graph, and you're gonna come like this, and you're gonna come like that. Okay, and then come here. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Come on, and then do that. Now let's see if you did that right.
I will then have the answer with all the explanation to see if you get the same thing as I do. So what if you get that? Just look over what I
1, 2 over 1, 2, 3. Oh, you're supposed to go out
have. I've got the
half.
period here is 2 pi.
Okay, that is supposed to go out half the distance and then do it. Okay. So here's what you're gonna do. 1, 2, 3, 4. So 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. And then you're gonna come out like this. And then for this, you're gonna come out like this. And then 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. You're gonna come out like this. And you're gonna go like this. Mm. Okay, so write an equation, and now we're on to the practice. Okay, so write an equation that represents all asymptotes. Okay, so theta equals pi over 2b, so pi over 6 plus pi over 3n. Theta equals pi over 12 plus pi over 6n. theta equals 5 pi over 2. 2 plus pi over b by 2 plus and angle theta is in standard position. What is the slope of the terminal ray of the angle? So just find tan. So tan of pi over 6 is root 3 over 3. Tan of 3 pi over 4 is going to be -1. 5 pi over 3 is going to be root 3. And then it's going to be 5 pi over 3 is in this quadrant, so it's going to be negative. Okay, this is back continued. So tan of pi over 2 is x is 0, -1, 0 over -1 is 0, right? Yeah, 0. Tan of 4 pi over 3 is pi over 3, and that's in this one. So it's going to be positive. Tan of 5 pi over 4 is going to be 1. And that's in this one. So it's going to be positive. Tan 11 pi over 6 is root 3 over 3. That's in this one, so it's going to be negative. Graph each trig function. So what we're going to do is graph it, which should not be too hard. Shouldn't be too hard. Graph each trig function. -1/2, so you're gonna pi over 2, pi over 2, boom, go up 1/2, so it's gonna come here, go here, oh, go here, go like that, go like that, repeat that, so over here, boom, boom, boom. Okay. And then and and then become oh
Windows. You can do this by going here. Click on Sounds. Then this sound window should appear clicking with the mouse here. You can do this by going to the sound icon and then right-clicking with the mouse here. Click on Sounds. Then this sound window should appear. So you need to click on Recording and then find your microphone. In my instance, it's this 3-toner audio device. So you'll notice that the levels are going up as I speak into it. If you right-click on this device and go to Properties, this window will appear. So all you need to do is to click on Levels here and make sure this is on 100. As you can tell, when it's down to 83, I don't know why my Windows periodically resets it, but it does.
Oh, crazy. Okay. So that's how it works. Okay. Now that I know that, that's good. Boom, 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 boom. Oh, that's cool. Okay. That's very cool, in fact. That is very cool. That is insanely cool. Okay. That's super cool. Super cool. Super cool. Super cool. That's super cool. Super cool. Super cool. Super cool. Okay. So let me come back to this. Okay. Alright, little detour, little break. Okay. We have 1/2 minus 3, so we're gonna get 2 pi over 2, which cancels out. So we're gonna get pi. So we're gonna come here where we have pi, boom, 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 boom. We have minus pi, boom, 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 boom. And then we're gonna come 1, 2, 3. And then we come out 1, 2. 1, 2, 3, 4. Okay. We have to check if this is right. Let's just check if we did this right first, so that way we can go on without thinking, oh, did I do this wrong? And here we have powers. Oh, it's over here. Okay. Pi over 6 plus pi over 3n, pi over 12 plus pi over 6n, pi over 2 plus 5 pi n, root 3 over 3, negative 1, negative root 3. Okay, that's alright. Undefined pi over 2 is undefined. Pi over 2 is y is 0. It's y over x. Oh no, x is 0. Oh shoot. Yeah, it's undefined. Negative root 3, 1, negative 3 over 3. This graph right. Yeah. Back to this, so that was the answer. Let's see this bottom one. The graph of the function g is given in the xy plane. If g of x equals a tan b of x minus 20, where a and b are constants, which of the following could be true? If a is greater than 0, then b is greater than 1. We got minus 20. This is going to be 20. This is going to be negative 15. This is here, so it's about 5 vertical stretch, I would say. But what's the if you come out 1/2, you go up 1, right? So if you come out 1/2, you should go up 1. You're going up 5, so 8 is greater than 0, for sure. And if 8 is greater than 0, and then b is greater than 1. And if a is less than 0, then b is less than 1. Is it C? I think it's C. Is it C? It's D. Huh. Why is this D? If a is greater than 0, then b is less than 1. Okay, b is less than 1 because you flip it and then it becomes a stretch, right? But it doesn't become a stretch. Will we get that on a test? Probably not, so it doesn't matter. Alright. So pi over 2b is the first one, so 2b. Here v is nothing, so it's just pi over 2. Move right, pi over 4. Boom, 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 boom. Move right, pi over 4. Just subtract 1. Vertical stretch times 2. 2. 2. Doot. Dude. Pi over me, so it's literally just pi, bro. So we come out right here. Dude, here, go like that, go like that. One, two, so 1, 2, 1, 2, 3. Oh shoot. You come out 1, you go down 1, 2. Yeah. Oh yeah. Okay, here we're gonna factor out 2, so we go y equals 10 2 theta plus pi over 2 plus 2.
terminal rate. These two things mean exactly the same thing. It's just worded differently. So if you see evaluate tangent of an angle, it's the same thing as saying what is the
So
slope of the
v
terminal
is
ray.
pi
All right, so
over
let's do this
4.
one together real quick. What is the coordinate point of pi
You go
over
left
4?
pi over
So
2.
that is going to be
1, 2.
square root of 2 over 2, comma square root of 2 over 2. So if you can write
Pi
down the
over
coordinate
4, you
point,
go
that'll
left
probably
pi
help you
over
quite a
2.
bit. And then you're
1,
just saying, oh,
2.
well, that's just the y divided by the x, square root of 2 over 2 divided by square root
You
of 2
go
over 2.
up to
That equals
1,
1.
2.
Super easy.
Go out 1/2, you go
Okay,
up
5 pi over
2.
6. Where's that one?
You go if you go down 2, there seems to be no reflection. So you just go up and you just go down. Then we repeat that over here. Like so. So. And then you come over here and repeat that. Like so. Like so. Epic. Now, I don't understand. 3.8, the graph of the function g is given by... Oh, okay, so they're just opposites pretty much. Okay, that's whatever. If I put that wrong, but got this right, onto this sheet of paper. This is blank. So I guess we just don't use that. One, two, three, four. Find a equation that represents all asymptotes on the graph of the xy plane. So theta is equals to pi over 16 plus pi over 8 n 1 over 2, so 1 half theta. So theta is equals to pi plus 2 pi n. In the xy plane, what is the slope of the terminal rays? So find this, 2 pi over 3. So that is root 3, 2 pi over 3 is there, so it's negative. 5 pi over 4 is going to be over here, so it's always going to be positive, so that's 1. Evaluate 10, 5 pi over 6 is root 3 over 3. It's over here. It's going to be negative. Tan 2 pi is here. It's going to be 0. 10 pi over 6 is right here. It's going to be root 3 over 3. I get all that right, bro. Root 3, negative 3 over 3. Negative 3 over 3, 0, root 3 over 3, 1. Negative root 3. Pi plus 2 pi n, pi over 16 plus pi over 8n. Okay. And then graph this. Not too hard. So there's no b, so it's just gonna be pi over 2. Pretty simple. Oh, and then left pi over 2. So then you come here. Left pi over 2. And then left pi over 2. And then here you go down to 1, 2, out. There's no vertical stretch, so it's just 1. Boom. Okay, so you just do, no, what am I doing? You come out 1. You go out 1. You go out like that, and then you go out like that. And here you come out like this, like that, like that. And then boom, boom, boom. And here, here, here. How like that, like that. So y equals minus 4, 10, theta, 1/2 theta, minus 1. Okay. So that's 2 pi, or pi over 2b, so pi over, oh, that's nothing. Cancels out, so it's pi. Then you don't move right or left, so it's just pi. Boom, 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 boom. Oh shoot, I drew that wrong already. It's 2 pi, so obviously you're not gonna be able to fit anything. You subtract 1, subtract 1, subtract 1, come out 1, 2, go 1, 2, 1, 2, 3, 4, 1, 2, 3, 4. One, two, three, four. So bad, I'm feeling so bad, bro. So bad. So bad. Nah. I'm feeling okay, I guess. Bro, I don't know, bro. You move right, power 4. Power 4. Down 3, 1, 2, 3. And you come out 1, 1. 1, 1. 2, 3, 4. 1, 2, 3, 4. 2, 3, 4. Okay. done. This is right. All of this is right. Okay. Now we're on to 3.9. Find the inverse of evaluate the following expressions. 1/2 is pi over 3, right? 1/2 root 3. 3 is x, so it might be pi over 6. It's pi over 6, isn't it? Isn't it? Sine to the power of -1. 1/2. Evaluate pi over 6. Epic. Evaluate, find the inverse function, graph it. -1/2 for x. I think it means to say y. But let's do this. +1. +1. So x is equals to 2 sine y plus 1. X minus 1 equals 2 sine y. Sine y is equals to 1/2 x minus 1. Y is equals to sine -1 of 1/2 over x minus 1. So you move right 1 and it's times 1. Okay, let's actually find this. Wait.
All right, here we go. Let's take a look at the next section here. We're going to talk about inverse trig functions, which are pretty awesome. We've actually done this before, but we're going to go way more in depth. So I want to kind of do a quick review to get us started here. So I know you can do this first problem. This is old school geometry, but let's just humor me for a second. Let's review this real quick. So when I'm talking about a trig function, or always up, this will give us that ratio. Right, it's no longer up and down, it's left and right. And then the same thing, if you want to keep the pattern going the negative direction, I've got this going on. What? This is the domain, so the range can only. only goes 0 to pi. So I'm going to stop here at pi. Pretty good. Actually, these for negative 1 of x. Same for we start high and come low, but and then have a ballpark idea of these graphs. Awesome. Let's see if we can put it all together, including its graph. This is the big dog right here. I like it. If this makes sense, you're golden. So let's find the inverse function. So how do we find inverse functions of anything? Well, just don't really. In this case, is just y. And then what happens here? Not cool. As is. I just want to make sure that. So really, in the parentheses, I'm going to multiply by 1/2 x here. Do we over 2 and get used to the part about this is bad horizontal trans. You're gonna have he was at that out. That's awkward without him.
So you multiply the stretch by 2 and you come right here. Okay, I got it. Okay. Root 2 over 2 is pi over 4. But which pi over 4? Okay, but which pi over 4 is it? It's in the other room where the shoes are. Bro, can you give me like 30 minutes? By yourself? Isn't that boring? Oh, honestly, I'm gonna take a break. Maybe. Um, okay, can I finish this? And then I'm gonna come outside this first part. 10, okay, so negative root 2 over 2 cosine. So this can be 2 of them. Right? Gonna have 2 for this. For this one, cosine pi over 4, and then 3 pi over 4, 5 pi over 4. 6 pi over 4, 7 pi over 4. You wanna go out? Here, you wanna go out? And 1 over root 3 is inverse tan of root 3 is pi over 3, and 2 pi, 3 pi, 4 pi over 3. Those two evaluate off. Sine of root 3 over 2. This is going to be pi over 3 plus, no, pi over 3 and pi over 3, and then sine is a positive. So 2 pi over 3 plus 2 pi n plus 2 pi n. N is of integer, and 1 of 0 is 0 plus 2 pi n, and pi plus 2 pi n. N is of integer, and then we are going to take a